Hello, good day. Today's topic is operating systems, and under operating systems, Unix. So these are the various Unix flavors in the operating systems, and also, so you need to be at the end of this course. You should be able to use the operating system concept in process management, memory, and file systems, and outcomes of learning concepts. Let's go case. Introduction to Unix. Unix is a multi-user, multitasking operating system developed in 1970s at AT&T Bell's Lab. Written mainly in C language, making it portable, designed for stability, security, and efficiency, and key characteristics: hierarchical file system, powerful shell and utilities, strong permission and security models, and features of Unix: multi-user support, multitasking capability, device independence, portability, networking support, and robust file systems. And Unix system components are kernel, shell, utilities, file systems. So, what is kernel? Core of the operating system manages CPU, memory, devices, and file system. Shell, command line interpreter, and utilities standard commands ls, for less, and cp, grep, ps. File system organizes and stores data. So this is the architecture of the Unix operating system. So this is how you see in the system in your desktop, and you interact with the application via application with the operating system. The application might be a folder, file folder, or Windows Explorer, or Internet browser, or any other application installed on the Unix applications or the operating system. So it will connect with the shell in the operating system, and it will interpret the command. So bourne shell sh, bash, c shell csh, and com shell ksh, and these are the shell commands. And next it will with the system call interference, it will communicate with the system call interference, and then system call will connect with the kernel. So the kernel is the main core of the operating system, where it has process management, memory management, file system management, and device drivers, etc. It manages the from the operating system. And next is the hardware. So whatever commands you pass, it will be translated and send it to the hardware components connected to it. So what are the user applications? These are programs executed by the user. Example: text editor, V Nano, and compiler GCC, and browsers, utilities, user written programs. Applications do not access hardware directly. They request services through the shell or systems calls. And shell command interpreter, the shell acts as an interface between the user and the kernel, and responsibilities: accepts users commands, interprets commands, executes programs, provides scripting capabilities, and common shells: bone shell sh, bone again shell bash, she shell csh, con shell ksh. The shell translates user commands into system calls. A system call interface provides a programmatic interface to OS services, acts as a bridge between user space and kernel space, ensures controlled access to kernel functions, which are examples of the system calls like process control, like fork off, exec, execute off, and file operations: open, read, write of, and device control, IOCTL, and protects the kernel from the direct user access. So, what is kernel? Core of the Unix operating system. Kernel is the heart of the operating system, runs in privileged kernel mode, and responsible for resource management. And major functions of the kernel: process management, memory management, file system management, and device management. What is there in the process management? It does creation and termination of processes and CPU scheduling, context switching, memory management, allocation and deallocation of memory, virtual memory handling, paging and swapping, file system management, file creation, deletion, access, directory structure, um, inode management, device management, controls IO devices through drivers, provides uniform access to devices. And hardware physical components of the system, that is CPU, main memory, RAM, disk, storage, IO devices, keyboard, mouse, printer, hardware resources are managed entirely by the kernel. So file concepts in Unix. In Unix, everything is treated as a file. A file is a collection of related information stored on secondary storage. File provides a uniform interface to access data and device. Examples are text files, documents, programs, etc. Device files, keyboard, disk, printers, and directory files, folders. Why files are important in Unix? Because permanent storage of data, sharing information between users and processes, and security and access control at device independence. And types of files in Unix. Unix supports several file types. Regular files store data or program code, example .txt, .c, or .pdf. Directory files store file names and references to the other files. Organize files hierarchically. And directory files, sorry, device files represent hardware devices located in their slash div. Types character devices, keyboard, mouse, or block devices, hard disk. Link files are hard links, symbolic, soft links. Special files, pipes and sockets for inter-process communication. Next are file naming rules in Unix. File names are case sensitive, uh, can contain letters, digits, underscores, and dots. No restrictions on file extensions. Maximum length usually 255 characters. Hidden files begin with dot. File attributes metadata. Each file has associated attributes. File name, file type, file size, owner and group, access permissions, timestamps, lost access time, lost modification time, lost status change time, and Unix file permissions. Unix uses a permission-based security model. Permission read or write W modify file and execute run file as a program. And Unix file permissions. Unix uses a permission based on security model. Permissions are assigned to owner, group, others. Example minus RW XR dash XR dash dash. So this is the command, the example command for the same permissions assigned. A file access methods, sequential access, read write data in order, direct random access, access data at any position, indexed access, indexed access, uses index to locate blocks, and file operations in Unix. Common file operations include create, open, read, write, close, delete, rename. Inode concept. Unix file system stores file metadata in inodes. Inodes contains file size, permissions, owner, pointers to data blocks. File name is not stored in inode. Inode concept like file structure in Unix. So this is how the file structure is. So this is the root slash, you can see at the top, that is called the root folder. Under the root folder, you have bin user home, and under bin you can see other things. Under user and home, you have library, local, alice, etc. And user has other documents, user created documents. Contents of an inode in the Unix file system. File type inode, permissions file type, owner group ID, owner user ID or group ID, and next the file sizes. If we have the file size details, and timestamps, access modifying those details, and link account and pointers to data blocks, pointers to Introduction to Unix file system. The Unix file system is organized as a hierarchical tree structure. At the top of the hierarchy is a single directory called the root slash all files and directories originate from the root directory. Unix follows the principle everything is a file. And key characteristics hierarchical organizations, uniform file naming, device independence, multi user support, strong access control and security, hierarchical tree structure, the root directory slash is the parent of all directories. Each directory can contain files, subdirectories, structure resembles an inverted tree. Unix follows the principle everything is file. And key characteristics hierarchical organization, uniform file naming, device independence, multi-user support, strong access control and security, hierarchical tree structure, the root directory is the parent of all directories. Each directory can contain files, subdirectories, structure symbols, and inverted tree. And root directory slash starting point of the file system contains system and critical directories. Only system administrator root user can modify core files. Important Unix directories slash bin, essential user commands, lscpcat, sbin system administration commands, and slash etc system configuration files, slash dev device files, slash lib shared system libraries, slash user applications and libraries, slash home user home directories, uh, and slash var variable data, logs, main, spool files, slash tmp temporary files. So slash bin and slash sbin. Bin basic commands required for system operations. Sbin system binaries used by administrators. Example slash bin slash ls slash bin slash fsck. Slash etc directory stores system configuration files, text-based configuration. Examples slash etc slash password uh, or user accounts, slash etc slash fs tab, file system tab, and slash etc host name mappings. Hosting mappings. A slash dev directory contains device files. Devices are treated as files types are character devices, keyboard, mouse, block devices, hard disks. Example slash dev slash SDA slash dev slash TTDY. And slash user directory contains user programs and utilities. Subdirectories slash user or build slash user or link slash user or local, often mounted as EW. Slash home directory contains personal directories for users. Each user has a separate home directory. Example slash home slash lice slash home slash bob, and slash var directory stores variable data. Data changes frequently. Example log files slash var slash log, mail files, spool files. Slash tmp directory that is stored as temporary files is automatically accessible by all users. And path names absolute path starts from root slash example slash home slash allies dot slash doc dot txt, relative path relative to current directory example doc dot txt. What is a shell? What is a shell? What is a shell? A shell is a command line interpreter. A shell is a command line interpreter, acts as an interface between user kernel responsibilities, accepts user commands, interprets and executes commands, supports scripting and automation. Classification of Unix shells. Unix shells are mainly classified into Bone family shells, C family shells. Bone shell SH introduction developed by Stephen Bone. Original Unix shell founded slash bin slash SH. Features simple and lightweight. Supports cell ilk scripting. Basic input output redirection. No advanced interactive features. Bone shell SH advantages fast execution, highly portable, preferred for system scripts. Limitations no command history, no auto completion, limited user interaction. Bone again shell bash introduction, enhanced version of Bone shell, default shell in most Linux distribution, backward compatible with SH. Features command history, auto completion, job control, command aliasing, redistributing capabilities. Born again shell bash. Advantages user friendly, powerful scripting, widely used. Limitations slightly heavier than SH. Corn shell KSH introduction developed by David Korn combines features of SH and CSH. Features advanced scripting, command history, arithmetic operations, arrays and functions, and Conch shell KSH. Advantages: efficient scripting suitable for complex automation, faster than Bash in some cases. Limitations: less popular in Linux environments. A C shell CSH introduction syntax similar to C programming language, designed for interactive use. Features: command history, alias, job control. C shell CSH advantages: user-friendly syntax, good for interactive commands. Limitations: poor scripting in support, not recommended for system scripts. 10x C shell TCSH introduction, enhanced version of C shell. Features: command line editing, auto completion, better error handling. Advantages: improved usability, popular in academic environments. G shell ZSH modern shell introduction, extended bond shell, combines features of Bash, KSH, and TCSH. Features: advanced auto completion, spell correction, themes and plugins, highly customizable. Advantages: excellent user experience, powerful scripting. Limitations: not default everywhere. Comparison of Unix shells, shell SH type, bond scripting, basic, interactive, popularity. So Bash is so powerful. Why does Linux still supports multiple shells? So this is one scenario where the key reasons for continued diversity is historical and philosophical differences. The original Unix philosophy emphasizes small, simple tools that do one job well. Different shells embody different approaches to this philosophy. The Bone shell SH, for example, is known for its simplicity and reliability, making it a foundational element of the Unix environment. Specialized use cases. Different shells are designed to excel in specific scenarios. Resource constraints. Smaller shells, such as the Almquist shell ASH or the Debian Almquist shell Dash, have a smaller memory footprint and are faster than Bash. This makes them ideal for bootstrips, embedded systems, or resource-limited environment. Interactive use shells like ZSH and Fish offer advanced interactive features such as enhanced tab completion command, highlighting and configuration frameworks like OMyZSH that are popular for daily command line popular used by power user. Specific syntax CSH and TCSH use a syntax that is more familiar to programmers accustomed to the C programming language, catering to different user preferences. Standardization and compatibility. The POSIX standard portable operating system interface defines standard shell syntax and behavior. So, while Bash largely adheres to POSIX, it also has numerous non-standard extensions. Maintaining a minimal, strictly POSIX compliant shell ensures that scripts written to the standard can run on any compliant system, regardless of whether Bash is installed or default. User preferences. The choice of shell often comes down to individual user preferences and familiarity. The open source nature of Linux systems allows users and distributions to select or develop the tools that best fit their needs. In summary, while Bash is versatile, the continued existence of other shell reflects a commitment to flexibility, efficiency in specific contexts, and unique traditions of providing a choice of specialized, effective tools. So, to summarize, describe the roles of Unix shells as a command line interpreter and classify the different types of shells into bone and C shell families. We have covered advantages, limitations of major Unix shells such as Bone shell, Bash, Con shell, C shell, and TCSH. Compared Unix shell for given use cases such as system administration, scripting, and interactive usage.